Hello.
Hi, Mitch. How are you doing tonight?
Good. How are you?
Good. So is this our last session before finals?
Yeah.
Okay. Let's talk about average rate of change. Is this where we should begin, number 10? Mitch, should we begin at 10? Mitch, you still there? You seem to have lost audio.
Is this working?
Ah, better. I can hear you now. I couldn't hear you for a bit. Can you hear me?
Yeah, I'm not. Yeah.
Okay, cool. All right. I don't know what you did, but it worked.
We updated our computer and it freaked out on me.
Okay. So what does average rate of change mean?
The amount something slopes.
Ah, the key word there is slope. Or rise over run. In other words, slope is the same thing as rate of change. So figure out what the slope is from 0 to pi. In other words, rise over run means f of a minus f of b, that's the rise, all over the run, a minus b.
So would it be pi over 0?
Well, the rate of change of f of x going from 0 to pi is what? What does f of x do?
Stay the same.
Aha. So the rise is 0.
Oh.
Right?
Yeah.
2 minus 2. What's the run?
Pi.
Correct. So that average rate of change is 0.
All right.
What is it between 0 and pi over 2?
It'd be...
So it's the second value. It's f. Here, let's write it like this. It's f of pi over 2 minus f of 0 all over pi over 2 minus 0. That's what it's always going to be for these kind of problems. So what's the numerator?
-4.
Good. Over
Pi over 2.
about this one. From pi over 4 to 3 pi over 4.
So it'd be 0 for the top.
Good. Which means that the average rate of change is going to be 0 except in one instance, and that is if the denominator is 0. In other words, 0 divided by anything equals 0 unless that anything, 0 over 0, is the only thing that you don't know the answer to. Okay?
So redefined?
No, if it's 0 over 0, you're into calculus. There's ways to figure the answer, but that's the only one we don't know what it is. If it's 0 over some number, it's 0. If it's some number over 0, that's the one that's undefined. But in this problem, going from pi over 4 to 3 pi over 4, remember it's f of the first minus f. In other words, that means f of 3 pi over 4 minus f of pi over 4 divided by 3 pi over 4 minus pi over 4. That's what you want to know, is this. Okay, so what's f of 3 pi over 4?
0.
Minus 0 all over. As long as the denominator is not 0, which it isn't, it's pi over 2, then the answer is 0.
All right.
All right. Hold on. So for this one, D, the average rate of change equals what? Remember, it's almost easier if instead of y we say f of x. So let me make it f of x. Give me the average rate of change in terms of f of x.
Would be 0.
Hold on, let's do it this way.
F of pi over 2.
What's the next one?
F of 0.
Good. All over.
Would be 2 cosine pi over 2.
The denominator is just the difference in the x's. In other words, it's pi over 2 minus 0. It's important to see this. This is what, and the reason it's important because it plays into calculus. This is all about calculus. Okay? So when we're talking average rate of change, it's the difference in the y values. There's the one y value, there's the other y value, over the difference in the x values. You could write that like that. The only reason it's easier to call it f of x rather than y is because we can say f of pi over 2 or f of 0. So this is the formula. Now, what is f of pi over 2?
Would be 2 cosine pi over 2.
Yes, what is that number? What's the cosine of pi over 2?
I don't remember.
Do you have a calculator in front of you?
Yeah, I'm getting
Is
it.
this a portion that you're not supposed to use your calculator? Yeah, you're not supposed to use your calculator. What do they allow you on this test? Do they allow you a cheat sheet at all?
Nope.
So you have to memorize this.
Yeah.
So you need to know what cosine and sine are of all the quarter points. So you need to know this. And to know that, what you really need to know is the shape of the curve. What's cosine of pi over 2? I'm not labeling the quarter points, but you can certainly do so.
Cosine. Cosine by that one.
What's this point right? What here? What's that point there on the x-axis?
Pi.
So what's the point right here where it crosses the x-axis?
Pi over 2.
That's what you need to know. You need to know this curve at the 5 quarter points. And notice that at the first quarter point, 0, it's 1. At the second quarter point, it's 0. At the third quarter point, it's minus 1. At the fourth quarter point, it's 0 again. And finally, at the fifth quarter point, or back where it starts, it's the same thing it starts at. So you need to memorize this curve to get all of your sine and cosine of these quadrangles. That's one curve. Here's the sine curve. They're very similar. The main difference is that the cosine starts out at 1, the sine curve starts out at 0. But you would do well to memorize both of these. Everything you see on my screen right now. And what do you suppose that is?
Pi.
And what is that?
Pi over 2.
And what is this?
3 pi over 2.
All right. This is key. Not just for what you're studying now, but next year. Very key. You want to have these two things memorized. Okay? So, the average rate of change of this was 2 times 0, right? In other words, it was f of pi over 2 minus f of 0 all over pi over 2 minus 0. What is f of pi over 2 for the cosine curve?
0.
Good. What's f of 0 for the cosine curve?
Is it 1?
It's 2. In other words, the cosine of 0 is 1, but we're multiplying it by 2.
Oh,
It's 2 times 1. So it's minus 2. That's the numerator. What's the denominator?
Pi over 2.
What's the answer?
Negative 2 over pi over 2.
Negative 4 over pi. In other words, when I say simplify that, I mean turn it into a single rational quotient.
Yeah.
In other words, flip the bottom and multiply. When you flip the bottom and multiply, you get minus 4 over pi. All right, let's do this interval. What goes in all my spots here? What goes up top?
It's 3 pi over 2 in the first one. And then pi over 2 in the other one. And then 3 pi over 2 minus pi over 2.
Now, what is f of 3 pi over 2? That's this curve, but remember, it's not this curve. This is your basic cosine function. So let's figure out what cosine of 3 pi over 2 is, and then multiply it by 2.
Is it, so it's 1, and then times 2 is 2.
Hold on.
What?
We're on the cosine curve.
Oh, yeah, so it's 0.
0.
0.
Minus what? What's cosine of pi over 2?
0.
Okay. So the numerator is 0, the denominator is not, therefore the average rate of change is 0. And finally, the last one, which is pi minus 0 over pi minus 0. What is f of pi?
-1 times 2 is -2.
What is f of 0?
2.
All over pi. So this answer is what? -2 minus 2 over pi becomes what?
-4 over pi.
That's the average rate of change. These are pretty easy.
For the first one, don't you just add 360 and then subtract 360?
It's this one.
130?
170.
Oh.
Make sure when you do these kind of calculations, Mitch, what you should do when you're done is add that number to that number to make sure you get 360. Okay? In other words, when you said 130, we knew instantly that wasn't right because 130 and 190 add to 320.
Yeah.
Okay, so here's your two answers. There's one positive coterminal and one negative coterminal. Okay, how about when they give it to us in radians? What am I going to add? There's two ways to do these. You can convert everything to degrees and then convert it back to radians when you're done. But that's a lot of work. The better way to do it is to do it completely in radian. So what do I have to add instead of 360?
18 pi over 9.
All right, 2 pi.
Yeah.
And what I have to subtract?
Same thing.
So what's this one equal to?
25 pi over 9.
That's the positive one, and this one is?
-11 pi over 9.
Good. Neither one of those can be reduced, so. And how about a negative angle?
Plus or minus 360.
Good. And how about a negative radian angle?
Plus or minus 14 pi over 7.
Very good. Everybody else would tell me 2 pi. But you've already converted it to a common denominator. Okay. We don't need to go over those. You know those. Solve the right triangles. How do we know which side is B and which side is C?
Most aren't all right triangles, don't they have C as the opposite of the right angle?
I don't know. I was actually asking because I didn't know. I think they mean this. which would mean b, little b would be opposite angle big B. So little b would be 5, little c would be 8. In other words, they're giving us the two short sides. But I'm not positive, because what if they've labeled this triangle and they haven't really been specific? What if it's this? That would still be triangle ABC, only then this side would be 5 and that side would be 8, and it would give us a different answer for the third side. So, hold on a moment. Let me give the lengths to the nearest hundredths and angles to the nearest tenths. I'm going to assume that A is the right angle, only because they don't really tell us. And I don't honestly think there is a standard. The only standard I know of is that you have to go clockwise when you read the triangle. In other words, I could call this triangle ABC, I could call it BCA, or I could call it CAB. So when they tell me right triangle ABC, I'm going, only because I don't know, I'm going to assume that angle A is the right angle, which makes this one 5, this one 8. What does this become? When it says solve it, we need to come up with all three sides, all three angles.
So just X?
Well, no. Use the Pythagorean theorem. Remember, when you're solving right triangles, the answer is always square root of something. What's it the square root of? In other words, it doesn't matter if we're solving for the hypotenuse or one of the short sides. The answer is always square root of. Remember that c squared equals a squared plus b squared. That's the Pythagorean theorem. We're solving for c. What is it?
So be 89 and the square root of 89.
Right. 64 plus 25, 89. I can't simplify that. That's prime. Now, they still want the angles. What's angle? A is 90 degrees, obviously. What's angle B? Use a trig function.
So good to. So tangent.
Equals what?
5 over 8.
Okay, so how do you get B?
Take negative or
Not negative, the inverse tan. In other words, when we're solving for angles, we use inverse tan. When we're solving for ratios, we take trig functions of angles, we take inverse trig functions of ratios to get angles. So in this case, we're trying to solve for this angle. We need an inverse trig function. It's always the same one, of 5/8. What's that angle? Make sure your calculator is in degree mode.
I need to go actually, should I just go grab my actual calculator? Or?
Whatever you're going to use on the final, Mitch, this is the time to have it.
Okay, I need to go grab that.
No.
It would be 32 point,
to the nearest tenth. Angle
Yeah,
to
so-
the nearest tenth.
so 32 degrees.
What's angle C?
$52. Or what?
Remember,
No, 58.
the two short angles
Yeah.
are always complementary.
Yeah,
58.
I put in my calculator wrong.
58 degrees. Now, we have all three sides, we have all three angles, but we haven't answered their question. Give lengths to the nearest hundredth. Give lengths to the nearest hundredth. So what do we need to do here?
Take the square root of 89.
What do you get?
$9.43.
You rounded that off to the nearest hundredth?
Yep.
Good. All right, so that's the way we do those kind of problems. Now let's do this one. I've only got like 4 minutes, and unfortunately I have another session at 4:30. Is your final tomorrow, Mitch?
Yeah.
Okay. Here they say angle A is 17, which leads me to believe that we misread the previous one. In other words, obviously, angle A isn't the right angle, so we probably don't have the right answer on the previous problem.
Yeah.
So you might want to redo the previous problem, starting with A at the top. I don't know. I'm not quite sure what's going on. But angle A is 17. Side B is 10. What's angle B?
$73 degrees.
Notice that we cannot use the Pythagorean theorem yet. We only have one side. So I got to figure out another side before I can use. I've got all three angles, but I only have one side. So how can I solve for either of the other sides?
Could you put 10 over 73
No.
times
Well,
X.
yeah, okay.
X
Yeah.
over 17?
Yeah, you could. You could use the law of sines, but that's not the easiest way to do it. The easiest way to do it is find a trig function that relates 10 to either other side.
It would be cosine.
Of what?
10.
Remember, you always take trig functions of angles.
Okay, so 17. Yeah.
Equals what?
.95.
What is it equal to? Cosine of 17 degrees equals what in terms of my drawing? 10 over z, right?
Yeah.
Okay, which means when you solve for z, it's 10 divided by the cosine of 17 degrees, which is just a number. So is that equal to what you said?
What? It would be 10.45 or 10.46.
10 divided by the cosine of 17 degrees is 10.46?
That's what my calculator says.
Okay. And now we have to solve for this side. And we have two choices for solving for the third side. We can either use the Pythagorean theorem or we can use a trig function. Choose a trig function.
Okay, so
Give me the equation that I would write.
sine
Of what?
sine of 73.
It's going to be equal to what?
Uh, 10 over 10 4/6.
Does that let me solve for anything?
No. So it would be tangent. Tangent would work.
Okay. In other words, this is the side we're trying to solve for. So we need a trig function that relates x to either 10 or 10.46. So what trig function? Tangent of what?
73.
Equals?
10 over x.
All right. Now we can solve cross multiply and you get x equals 10 over tan of 73. And remember, these things are just numbers. That's just a number. And that will let you solve for that third side. Now, and just so that I don't leave you, I gotta go, but in this triangle here, it's probably, if it's ABC like this, then the sides are, B is 5. Oh, it's still the same. The two short sides are 5 and 8. So it doesn't change the answer at all.
Yeah.
In other words, once you determine which are the short sides, that's the key with right triangles, is which are the short sides, which is the hypotenuse. Mitch, good luck on your final, and if I don't talk to you again, have a nice summer. Maybe I'll talk to you next fall.
All right. Thank you.
You're welcome. Have a good one. Bye-bye.